This
So what
conference
is
will now
analog?
be recorded.
Okay. So we have in the VLSI industry we have two type of domain. One is front end, another is back end. So you might know about software industries. There are also like front end developer, back end developer, or you might know some developer or some testing guy. This is like a domain are present in software industry. Similarly, in the VLSI industry also we do have front end and back end. So what is front end? So front end means this is the front end part. Means initial will be design this guy. Then back end is purely dependent upon this guy. And even they have some own logic also. And they have some relationship with front end guy. Okay, let's take an example. We have many domain in the VLSI industry. There is a digital domain, we have a analog domain, we have memory, IO domain are there. So digital front end people are called RTL design and back end called PD, physical design engineer. So RTL people will write the code, some Verilog code, whatever they are writing, and they have some inputs like synthesis. So digital thing they will deal with RTL people. And whatever the code they will write, whether it is correct or not, that is called DV, digital verification. For PD, they will do backend and some verification, that is called physical verification. Digital some verification means whether okay, I'll come to this point. What is verification? Next, for analog, that is called analog design is the front end people. For backend is analog layout. So our course will be mostly 80% will be analog layout. Similarly, memory design, memory layout, even IO layout, your IO design, memory design, like this. Okay. So what is the analog people will do in that verification? Means what is the verification we are telling? So we'll do also what is the work we'll do, means what is the industry, what is the analog people will do. That will come to later. But it is timing you understand whatever we are doing in the analog domain or any memory or IO, they are doing same part. PD people also doing same part, but they will do extra thing. What is the extra thing? They will do STA, static time analysis. Another thing, we are doing by manually. Manually means by using, we don't need any coding. So they will use PD people who is all the port plan. I'll come to that point. What is the port plan? All this thing. Just basic difference, they will use some language, a scripting language. So what is a scripting language? They can use for tickle, some basic language, Linux. This command they definitely need to know. And tickle is the basic they will be used. Sometimes Python, all this thing, scripting language they will be used. But we are not going to use anything about scripting. So we are doing about manually. This is the basic difference. So manually, when I'll show you the what is the tool our will do. So what is the work of a analog layout engineer? So now whatever I show, let's see a chip, full chip. So this is the or any this is block, let assume this is your full chip. Internally if you see this type of structure you will see. Okay, so generally what is the marker? One or marker is not working for this, like drawing any layer.
It's working, sir.
What is the option in the go to meeting?
I think you are using new version, right?
Yeah, new version, that is
I think we cannot able to see that screen or screen, sir. That mic and everything. But I will let you know in a minute.
the drawing option is not coming. Okay, so let time being you can see my cursor. So these are the whatever the my cursor, white cursor you are seeing. These are the IO domain. So input output. Suppose your chip you are using your laptop. So laptop inside there is a chip, or your mobile phone there is a chip is present. So any supply is coming, or any like output function. Suppose charging pin is like a input pin where the supply current will be entered to your chip. So these are called input output supply. Or for output some function. Suppose you are using some earphone through mobile phone, that is called output. Means some output operation we are collecting. Some internally, some actually this is for internally also function. Suppose you have using some apps. There will be 100 apps is there, so it will be controlled by through a chip also. There will be separate chip will be there. So this is like input output. Okay, next some digital block will be some area will be allocated to here. Okay, let I'll draw this. This is assume this is a chip. So whatever I am drawing, some input and output. These are called IO domain. And some area will be allocated to digital people. Some area will be allocated for analog. Some will be allocated to memory. There will be no purely digital chip, purely analog chip. You will get very rare. Even 2-3% you will get that type of. But maximum 95% chip will be some analog part will be there, some digital part. Because without this it will not operate. Because supply will be there, some analog will be there, some digital part will be there. Okay, so main you got some idea about chip. Let us assume this much area. So area means what? You have some x value you know, y value you know. So this is suppose you are building a house. You have certain square foot like 10,000, 1,000 square foot area is given. Means you are purchasing a flat. This much size they will give you. Similar here also for analog this much area is allocated. And these are if you see your chip how this technology at nanometer. This is actually this is called channel length. That also I'll come to later. But chip size will be your area will be in mm, millimeter square. Means you can understand that much area, very small area it will be there. Okay, let come to you have given. Let assume. So this is I'm telling about what is analog people will know. So we will be see some. We'll just compare it. How real time people means we are making a house. I'll just relate it to what is the layout people will do. Just take an example. So x is 100, y is 80. Let us assume. So this much area is given to. One second. Okay. So you want to build a house. So when you're building a house, you need to plan. So plan in the sense, suppose you want to make it this is 2 BHK house. So two room you want to, this is like a master room, another is like supporting or study room. You made some balcony size is there. This much area you allocated for balcony, some toilet like this. So this is like a planning. This planning thing is layout called floor plan. This is the first thing you have to do. Even this thing also they will do PD. If you join as a PD engineer also, they will do same thing. But this is there you are doing manually. But they will be using some scripting language. Second thing. But this planning, it is the first planning you did. But this is by analyzing it, it is you think it is not the correct thing. You not correct thing means you change idea and you tell like this is I need to increase the size of master bedroom and you'll reduce somewhere balcony I'll do like this. Okay, so this is like alternative floor plan, but at last you have to conclude is the final floor plan. Final floor plan means you are not supposed to change and again. That point is called placement. Placement means already placed. You are not supposed to 100 times change and turn. That is the final place floor plan. Next point is, so once the placement is done, means once the plan, like you hire a, you are building a house means you consult a architect. They give the plan. Okay, now you start the, this is the plan is done. Now you want to practically you have to means you have to start building. Like you have to two floor, like 2 BHK, first floor also 2 BHK, second floor also 2 BHK you want to do. So you have to you purchase brick and started using cement. All the like this is the connection you did. This thing is called routing in the layout. Routing means router term you might have heard. Router means connection. So whatever the placement you did, like this block to this is like a master bedroom. You have to do connection. How will convert? So brick you have to use some rod like that. Second point, when they are started making, so this brick they cannot use two brick, three brick like that, 100 brick only for. So there is a certain rule they will follow. Certain rule means after some distance they will follow. They will add cement or sand something they will add mixing. If you see the real time, they use some wire or a, to make it straight exactly. There will not be some bending all this. So similarly here also they will do a check for the layout, what is the routing or placement you did, that is exactly correct or not. So tool will be identified there itself. That is called DRC. DRC means design rule check. Whether you did routing or placement as per their technology. What is the term I added? Technology. So technology you can identify. This is also Moore's law. As per Moore's law, so they have certain technology. What is technology means? We have 180 nanometer, even 360 is there, 90 nanometer, 45 nanometer, 65 nanometer. So these are technology. Some company means some foundry having there. This is TSMC. One company is Taiwan Semiconductor Manufacturing Company. You have Intel is there. You have GF Global Foundry. You have Micron. Micron they have separate foundry. Intel. These are foundry company. But TSMC is the ruling. Ruling means he is like 80% company are dependent. Even Intel again, they cannot manufacture all their fab foundry. So they are depending also TSM. Some production they are doing TSMC. Okay. So some technology means this is the channel length of a MOS device. Generally will be what are the chips you will see. So I saw the example. Here everything are using by CMOS. You can see here. CMOS MOS means okay. CMOS I'll come to that. That's the combination of NMOS and PMOS. 80% chip will be NMOS PMOS. Again some resistor capacitor. If RF layout will come some inductor will be there. So we will discuss about DRC. Next is fifth. So till now, whatever we discuss, we didn't discuss about front end guy. so, so after all this thing, you have to do a check LVS. So LVS means layout versus schematic. So generally, front end people will give you schematic. So this is given by front end people here analog design, memory design, or IO design. So they will give you schematic too. That is like input to us. So that schematic and whatever we will do layout, that will be match. So this is also these two are called come under verification. When there is a tool is there, they will verify whether you have followed design rule check. That is the as per rule file you are followed or not. So LVS will check with your front end people and back you people whatever do. Finally, whatever the schematic people are done, you did. Suppose you did you change something, but schematic people also follow. That's like a vice versa. Okay, not only front end people will change, you people also suppose change, but you give some valid reason why you are changing. Because suppose you don't have area, there is many concept will come. But time being you understood this five thing is the layout flow. So first we'll do floor plan, placement, routing, DRC, LVS. So generally analog or if you see PD people, because that is purely they are deal with digital. So digital means they will be. So I told one extra is timing analysis because their clock signal is very important. So they will do timing analysis, static time analysis, clock synthesis. So generally clock related thing they will do extra thing. Okay. Otherwise the almost same thing whatever we are doing that is also backend thing. Okay. So next any doubt till now? Now we'll come to what is the syllabus for custom layout. Custom layout, okay, some people are having doubt. So custom layout is combination of analog layout and IO layout. Generally some company they are custom, they these two both work. Means analog layout they will deal with and IO layout also they will deal with. I mean there is no separate thing. Sometimes they will do standard cell also, standard cell layout. But this is very rare. This is also a different part. Even memory also a different domain. We will not cover memory also very deeply because our 90% course will be analog. The opening and everybody want to switch to analog. If somebody join as a memory layout, they will change to analog future. IO layout also they will switch. If you see standard cell layout, it's maximum because these are opening will be more and this is very growth. compared to other layout domain. Okay, so actually we have 6 month training. So initially basic, 2 months about basic. So there will be some languageical basic language, everything you will cover. The digital basic, even some MOSFET basic, all this cover will be within 2 months. After that we will be start real time. Means what is the advanced course. So in the advanced also we will be cover some basic. Okay, so initially what we will cover, first we will cover some KVL, KCL, voltage division rule, current division rule. You might have studied some RC circuit analysis. This is some basic class you might have studied in the BTech. Low pass filter, high pass filter, clipper, clamper, diode. These are some basic you will be cover. And then we will be cover CMOS fabrication. So what is the CMOS? CMOS generally is the combination of I'll just give idea. Okay. So this is the symbol of a so MOSFET generally having four terminal. One is drain, source, gate, another is bulk or body. It is a voltage control device. So this is the symbol of a NMOS. PMOS means there is a bubble is there. If both will combine, that is CMOS. CMOS means complementary metal oxide. That I'll come to now. But what is MOS? You know BJT and MOSFET. But MOSFET is a voltage control device. How we can relate? So you know the MOS pipe, like water pipe you have seen. See, this is the water tap. So water is going inside this. This tap is controlling. This is act as a gate, and here these are called channel. Channel means water flow is a channel where that is called electron or suppose NMOS N channel, PMOS is hole, the P channel MOS. So source to drain current will flow. See, here to here current will be flow, drain to source or source to drain. But this is controlling. This is like a tap. How controlling? We'll see. Suppose this is NMOS. If I draw the NMOS, how it will be looks like. That is the symbol or that is schematic view. But if you are drawing the cross section of a NMOS, So we are having three terminal till now. Another is bulk. So this is present in P substrate. So P substrate is a lightly doped. We cannot pass current lightly doped because this is very high resistance. So ink plus means here doping concentration high. So actually we have three type of material. One is insulator, second is conductor, another is semiconductor. So semiconductor will not carry current easily. This is the behavior in between insulator and conductor. So to increase its conductivity. So if you see the silicon, okay, those are having doubt. I'll go to just little basic. So just now I discussed three type of material. One is conductor, insulator, semiconductor, and conductor. So this is actually even depends upon the energy band gap also. If it is overlap, that is called conductor. Another way we can define, if you pass the current, it is good carrier of electricity, that is called conductor. And insulator, if you pass the current, it will not flow. So example, diamond, wood, glass. But semiconductor, it will be behavior in between. In between means conductor or insulator. So see, this is the periodic table. So if you see the group 4 element, silicon and germanium, these are called semiconductor. But we need to behave as a conductor. Then there is a concept called adding the doping. Doping means adding impurities. Impurities means some, see, this group 5 element is arsenic and phosphorus. If you add to silicon, it will be n type of semiconductor. This is called group 5. V means 5. IV 4, 3. Here aluminum or boron. If you add it to silicon or germanium, it will become P type of semiconductor. So whatever I told here, so semiconductor divided into two type. Intrinsic means pure semiconductor. It is formed between, so it is by covalent bond. So I'm not going that much depth. So all are similar metal. But intrinsic semiconductor, extrinsic, it is two type, N type of P type of semiconductor. So when you adding some impurities, see here some group 5 element is adding to silicon. Group 5 element is arsenic or phosphorus or pentavalent, so that the conductivity will be increased. That is the point. So whatever discussing, this plus symbol you are seeing, its conductivity will be increased. So if conductivity increase, if you apply some voltage here, current will be start to flow. But now this is called channel. Okay, this is your P plus. The bulk terminal P substrate is lightly doped. To increase the conductivity, P plus. So all plus symbol is conductivity increase. Okay. Time being, how we'll see the operation. You can see the gate is how it is controlling. So gate and channel, it is isolated by some insulator, some silicon dioxide. This is an insulator or dielectric. You might have some like sand or some silicon insulator metal, silicon dioxide, also insulator. So current will not pass gate to channel. So if you apply some voltage here, positive voltage, so like the north pole will attract, south opposite will be attract, same will be a ripple. So here positive in p sub 1000 number of hole are there, 10 number of electron. This is called minority carrier. Minority means it's, but majority are hole. Minority, see, like you religion, some minority religion, majority. Similarly here the p substrate, majority are hole are there. Minority means the numbers are very less. This is called minority. So 10 number of holes, sorry, electron are present here. These are present like this somewhere. So this positive charge it will try to attract here negative. Okay, by applying gate voltage. So this is like you applying some voltage, your energy will produce or force will be produced. That force will be attract. Similarly, simply positive charge will not burn. This, so you positive means you are applying some voltage here now. See, this is a positive. This charges will be inverted. Suppose 1 volt. If I increase 2 volt, so more positive charges will be come. Similarly here, gate if you apply some voltage, positive voltage, it will be attract negative voltage. Sorry, negative charges. These charges will be deposited here. This is our channel. So, but at which point it will be channel will be created, that is called threshold point or threshold voltage or VT. Okay, but you are applying positive voltage. In digital, we have either two, 0 or 1. So 1 is taken as positive, 0 as a take negative, or some very less voltage are taken as 0. So this is concluded NMOS will be on by, this is the NMOS because N channel. It will be turned on by if you apply 1. Yet anybody having doubt? Because positive voltage if you apply it will be turned on. Otherwise current will not flow. Just give you idea what is the material I will share. See, MOSFET stand for metal oxide semiconductor. See, its name also like this. In this diagram you can. So here generally will be use some metal. These are SiO2, is oxide, silicon dioxide. Its name is coming from there. Metal oxide. This is N type of semiconductor. Metal oxide semiconductor. This name is coming like that. You don't mock up anything. If you understand any topic, metal oxide semiconductor. Okay, so it is having 4 terminal. Unipolar. Unipolar means current is flowing either one direction. Unipole. Bidirectional, even the path is only one. If you see BJT, BJT is a bipolar. Current is go to directly base. Their emitter collector. Okay, so this current will be divided. I equal to IC plus IB. So here to here, two way it will be flow, but here only one direction. That's a unipolar. Next, it is a voltage control device. So by applying voltage across gate, you are controlling the channel. Otherwise current will not flow. Channel you need to create by applying gate voltage. It is high input impedance because current is not there. Gate will not carry any current. There is no electrical connection. So input impedance is very high. If you see VGS, the apply voltage, because current is zero, resistance formula is V by I. If current is nearly zero, R equal to impedance, so high input impedance. Okay, so I'm not going everything detail. So whatever we discuss now, this is the enhancement mode. Channel is not there. Suppose somebody asks why we are not using depletion mode. So channel already present. Suppose let's take an example. Your chip is use your mobile phone. If you giving charge or your supply voltage is fluctuated or if any lightning come, suddenly huge number of charges will be come to your channel. So your mobile phone will be burned. You can see sometimes like lightning will be there. The TV you have to off or mobile phone should not connected to charger. That is the reason. Huge number of charges will be entered to channel. If channel burn means there is some channel charges will be entered to gate oxide. Your device operation will be fail. If it is like this, see even you supply voltage but gate is controlling. Charges will be tried to your supply voltage you apply here. Supply voltage means your charger you connected or your power supply. Here charges will be come but this channel is not turned on because gate voltage you didn't apply. So this is the safety. Everywhere enhancement mode. Okay. So whatever we discussed, this is NMOS gate drains source. This is SI to layer N plus N plus. Symbol already told, but this is connected only. Okay, for PMOS. I'll just tell you because what is our discussion? CMOS. So before that, PMOS also we need to know. Anybody having doubt till now? Are you getting? So PMOS means this name P means P channel. Same concept. It is present N substrate instead of this N oil. So this is will be cover CMOS structure why N oil is there. This is a bulk. So annual means n type of majority charge carrier. So 1000 is electron. 10 number are hole. Is called minority charge carrier. So if you apply here negative charge, what will be? It will attract hole means positive charge will be come here. Now channel will be created. So you are applying negative voltage. So this PMOS will be turned on. The symbol will be looks like here bubble is there. Okay. So if you apply 0, actually in the digital if you see, okay, so this is you got to know NMOS will be turned on at 1, PMOS will be turned on at 0. So what is CMOS? Actually, this is the discussion. CMOS full form is complementary metal oxide semiconductor. Okay, this is your input, this is your output. Why it is called CMOS also I will tell. So now input is you are applying a 0 and 1. Like this type of clock signal is applied to input. So let if it is 0. So this is assumed this is PMOS switch, NMOS also a switch. It is controlled by gate. This switch is controlled by gate. VDD, let assume your 5 volt, this is 0 volt output voltage. Now if it is 0, the PMOS will be on. So this switch will be on. Now output will be get 5 volt. So 5 volt, so digital, the higher voltage will taken as 1. So input you are sending 0, output you will get 1. Okay. Second, if I am sending 1, so 1 means NMOS will be on. So this switch will be on. So this is off. So now output is connected to, this is on. So output is connected to 0 volt. 0, you will get output 0. So when 0 you are sending, output is 1. 1 you are sending 0. This is called complement. 0 complement 1, 1 complement 0. That's why this structure is called as a CMOS. Any doubt? Yeah, anybody having doubt, any query?
No, sir.
Am I audible? Okay,
Yes, sir. Audible.
okay. Suppose you want to design, this is an inverter. So in this circuit, everywhere inverter will be not there. Some block will be there, suppose NAND gate. Okay, so you need to know about the design of the NAND gate. So till now, whatever KVL, KCL, these basic things, schematic dates, I'll come to this point. LVS also, some project. Okay, so these are the project. I'll come to that NAND gate, all these things. Okay, so what are the project will be cover here? So we will be level shifter, current mirror, speed trigger, operational amplifier. This here it is our analog block, operational amplifier, LDO, band gap reference, PLL, SARTES, ADC and DAC. Okay, so level shifter, actually what is the work of a level shifter? It is like a input. It will come under IO block. Suppose input block, if you see, I saw the chip diagram. So full chip layout. This is the full chip. So any signal is IO. It is like your supply voltage 230 volt. So you will not give directly 230 volt to your chip. So there will be some converter, like your mobile phone charger is there. It will be converted to some by step down voltage. Suppose 10 volt it is converted. This 10 volt will not connected to, because this IO block, through IO block some digital block will be there, some analog block. So analog block supply voltage will be different. Digital block supply voltage will be different. It is not the same. For connection that we need a level shifter. Level shifter will do, it will level up and level shifter down. It may be increase the voltage, it may be decrease the voltage level. Suppose take an example. You are sending 0 to 3 volt. You want to increase to 0 to 7 volt. That is done by level shifter up. So 0 to 2 volt you want. 0 to 2, 0 to 2, like that. This range voltage level shifter down will do. Okay, suppose this block will be utilized by digital block. This 7 volt will be utilized by analog domain. So this will be directly through level shifter will be done. So that's why it will be used in the IO domain. Input and output. Okay, next project is current mirror comes Smith trigger. Smith trigger is like any sinusoidal signal is there, it will be converted to square wave. Op-amp. Op-amp, this is a purely analog. Analog means, so what is the analog signal? Digital, 0 or 1, but analog, any sinusoidal signal. This is also analog. What is the analog definition? Analog, with respect to time, it will be the output voltage will be changed every time. It will be changed with respect to time. Means suppose this is 1 second, you will get some value. Suppose 2 second, it is not same value, it will be different. Even 3 second, every time, and it is each cycle. So this cycle, your all the value, so positive value then negative value, it is changing, it is not a fix. Next half cycle it might get some different value, but every time it will be different. Even 5 nanoseconds some different value. Okay, that is the definition of analog. Simple definition. So this is op-amp. Op-amp means operational amplifier. Amplifier means if input voltage you are sending, you will amplify or multiply, you will get some more voltage across the output. So your 5 volt, your 1 volt output, you will get some gain into V1 minus V2. Difference between two voltage, suppose 5 and minus 1, this gain is suppose 2. So you will get some amplified voltage. That is op-amp. LDO, low dropout regulator. So its use means, so in the supply voltage you are varying, the output voltage is independent of supply voltage. This is the application LDO. BGR, the band gap reference. So generally this application, mobile phone or your laptop. Okay, BGR means with respect to temperature. The output voltage remains constant. Suppose your mobile phone, you are using any negative temperature or very high temperature area, the operation of the output will not be changed. it will be fixed. It not, suppose it temperature increase, the voltage also increase or decrease. That will not happen. PLL generally for high frequency, like 4G, 5G signal generating. So this is the application for generating high frequency in terms of gigahertz frequency. Phase lock loop, SORTES. SORTES application is pen drive. Means data transfer. This is generally if you use a pen drive to your laptop. So when you transferring data serially, see you will see like 10 folder is there. Let's take an example. These are some folder is there. Okay, some document, some download folder is there. Okay, this folder I need to transfer to another folder. So when you transfer, it will be transfer serially. At a time, all together it not pass. Okay, so that is called serializer. ADC is a analog to digital. So any signal you are converting to analog to digital or digital to analog. So these are project will be covered. Some memory I have not written, SRAM and DRAM. Maybe last part it will be there. Static RAM and dynamic RAM. RAM you all know, random access memory. Okay, next what we will cover. Suppose you want to design a NAND gate. So you know the formula is A dot B whole bar. Dot means series of the NMOS. Plus means parallel. NMOS. For PMOS it will be a reverse. Okay, so you want to design this schematic. By using this only you can design. So what is A dot B? It is in series of the NMOS. So two NMOS I have taken. One is A, another is B. I have made series. PMOS it is parallel. If you see the inverter, this bar is coming because PMOS we have kept here, NMOS we kept here. Okay, some people are having doubt. What is I saw the previously? What is CMOS? If you are sending A, its complement is A bar. Okay, so PMOS is above, NMOS is below. Similarly, if you are designing A dot B whole bar, NMOS will be here, PMOS will be here. Somebody tell why if you keep NMOS above. If you keep NMOS above, PMOS is below. What will happen? This will be act as a same. Okay, if you are sending 0, this will be on. So output will be connected to ground. Ground means 0. Are you getting or not? If you are sending 1, NMOS will be on. This will be on. Output will be connected. This is your VDD, BSS. This will be on. This will be 1. So if you are sending 0, output 0. If you are sending 1, output will 1. This is act as a buffer. No use. 1 means your output is 1. What is the use of this? Okay. So now suppose you want to design a dot NAND gate. So dot means 2 NMOS in series. So below that's why I kept, and above PMOS Reverse means if both are series, we will make it parallel. So this is the symbol of a PMOS. It is in parallel. So series parallel connection you know already. This is VDD. This is VSS. This is your output. Okay, so whether I am designing this is correct or not, you can check. How? By using truth table. On one. This is the output. If both are 0, so 0 no, PMOS will be on. So this will be on, this will be short circuit. This is also on. NMOS A equal to 0 means this will be open circuit. I am putting cross mark. This is on means output will be VDD. Means 1. This is 1. Now 0 1. So A equal to 0 means this is on, B is off. A is on, B is off. So this output will not come to ground because this is open circuit. So only A will output equal to VDD because there is the path here to here. Here 1, even here also 1, this will become 0 because at the time both NMOS will be on, PMOS will be off. Understood? Anybody having doubt? So you can design also A plus B whole bar NOR gate. So you want to design a NOR gate. Plus means parallel of the NMOS. Same thing truth table you can apply, you can cross check. Okay, so this is the demo, everything I will not tell because this is the diagram of a layout. Our tool also looks like this. Anyhow, I will show you the tool how it will be. So our technology will be 28 nanometer. Synopsis tool. So we are going to use synopsis tool. Okay, so what is the some topic what we will cover? These are the advanced topic we will cover. These are the project list. Next we will be cover what is MOSFET, what is CMOS, BJT, what is BJT, bipolar junction transistor, what is diode. Okay, some device physics, CMOS fabrication. How, what is the fabrication means how. See, you are seeing this is a schematic view, but cross-sectional view when you see, so you will see like this type of structure. Inside P substrate, then NVL, then P plus N plus, then contact metal, so all this layer. So how that is forming, that is topic is CMOS fabrication. But this fabrication in industry is not present in India. So now they are some Mysore and Ahmedabad, they are starting fabrication. It is not already started. They are planning to start. See, next is stick diagram. So stick diagram is a, so this NAND gate utility. So this is front end people will give you schematic designer. But layout guy, you want to do floor plan all these thing. So stick diagram is the connection between schematic to layout, means front end to back end. You need to plan, means implement. This is like a, if you writing a answer sheet, you are doing some rough work. This is how planning. So immediately for stick diagram, you give you idea about rough work. How you need to place. Suppose VDD is here. Okay, I'll give you one example of an inverter. That is the stick diagram process. This is the new topic related. So whatever you don't know, this is purely related to layout. So generally current will flow from PMOS. This is a PMOS source to drain, and for NMOS drain to source. So drain is the higher potential for NMOS, source is the higher potential for PMOS. Okay, so this is the output, input. So we will be plan for plan how this is VDD and BSS. So stick diagram, I'll draw a line with stick. The representer, all we need to represent by a line or stick. This line has stick only. So this is a device. This is a PMOS. How will we? It is having three terminal. Forget about gate. So this line will be taken gate. Source gen is alternative. Mean you can. It is your choice. Suppose I am taking this one is the source. This is a drain. For separating PMOS and NMOS, we will draw a dot dot line. This is a NMOS. Even here also source, drain and gate. Now gate is connected to input. So I'll draw a line. This is your input. Now source is connected to VDD. If you put a cross line, there is a connection. Drain is connected to output. Source is connected to VSS. Now somebody tell if I take drain here, source here. If you use, your wire will be little bit more length. See, if you straight line, another is bending line. So definitely this one wire will be length. So if length is more, so what is the drawback? I'm just telling. Resistance formula, rho equal to L by A. The resistance directly proportional to length. Length increases, resistance will be increases. Now time is RC, time constant. So resistance increases means time will be increased. So you are sending a data, it is having 10 nanosecond. But in the output, you're getting after 5 minutes because of some delay. Because this is charging or discharging, charging it is taking. Suppose let's take a mobile phone. Mobile is charging 3 hours. For 100% charging, mobile phone is taking 3 hours. Another mobile phone it is taking only 30 minutes. So customer will purchase which mobile phone, which having less time taking for full charge. If you see iPhone or OnePlus phone, it will take very less time because of the not only cost, that is the reason the chip will be very effective chip. And you can see your processors, they are using Snapdragon 895, okay, some advanced about 865. What is that? If the processing is very high, then it will be charged very fast. Even channel length 7 nanometer, nowadays now 3 nanometer, 5 nanometer. That is the reason that is very costly. Okay, so this is the example I told. Stick diagram is very helpful for a small mistake, but it will be very, because in the chip you will be 10,000 number chip will be there. Okay, so this is the stick diagram. Now we can see the flow. The schematic designer, this is the front end guy. They, after completion, they will give you some file. So LVS, this is a compare means the layout people you did layout, layout netlist, schematic netlist. Both will be compared. Compare means it will be verification. That is also a part of LVS, layout versus schematic. This is just an example of a layout. We have some layout dependency. We will be study about latch up antenna, electrostatic discharge, EM, oil proximity effect, length of diffusion, shallow trench isolation, IR drop, design for manufacturing. These are layout dependent. Means if you draw a layout, there is some drawback. This will be latch up. So this will take one topic for discussion. Only latch up it will take 3 hours. Okay, so just giving idea. So till now I did say about bulk. So generally, if you, okay, I will show this topic in the diagram also, like layout topic. Means tool how it will be latch up error. FinFET. Actual FinFET, this is the last after we have a structure is planar. So whatever I show, source drain gate, that are planar structure. That is very simple. It is two-dimensional structure. FinFET is a three-dimensional 3D structure. It is having X, Y, and Z axis. Three-dimensional means what? X, Y, and Z. If you see X, Y, and Z, but planar only X and Y. Here X and Y. Okay, so this is just a, will give you basic idea, but the technology below 16 nanometer are called FinFET. 16, 10, 7, 5, 3, all these are FinFET. Okay, so I was planning to show some tool basic. Till now, anybody having doubt, any query?
Sir, actually, syllabus is physical design provided me, sir. I'm a e-learning student, sir. So, sir told me that the
No, no,
physical design, analog design, yes, sir.
no, no. Physical and design, analog design is separate course. This is custom layout or analog layout course.
So actually, they said me, sir, the 2 month syllabus is same for custom and physical both, sir.
Okay, okay, that is for basic. Basic means you'll get
Yes, sir.
learning about everything. Everything means common topic. So this is not a this is for every students whoever join they will be go through this 2 month course. That is the advantage. You
Okay.
learn digital course, tickle language, programming language, everything you learn 2 month basic course. After that, it will suppose somebody so you will join custom layer that advanced topic I will take care. So this 2 month course I will not take the class.
Okay, okay.
You
Actually,
got
sir,
the
I'm a
point?
e-learning student, sir. Yes, sir. I got it, sir.
Okay, uh, okay you will learning now. E-learning people you will not get. You'll get directly advanced.
Yes, sir. Actually, they provided me in my dashboard, sir, already.
Okay, okay. So you already got. Yeah. Any other having doubt?
Sir, excuse me.
Yeah.
Hello. Sir,
Yeah.
can
Yeah.
you
Carry on.
provide the synopsis tool access or as well as can you provide this that is cadence tools too, sir?
We are not current tool. We don't have, but we are
Okay.
planning very soon. But it is not confirmed yet.
So
Okay.
for this gas,
But
it may
what
be
you
possible or not, sir?
you talk to management once. I'm not sure they
Okay.
are trying to, but synopsis we have. That is, I can guarantee. But guarants we need to talk management. We talk to senior sir once.
So daily,
Okay.
daily is there live class or can you share only the recorded classes, sir?
No, no, live class will be there.
So after the class, can you share that class, sir? Recorded
I mean,
video.
recorded, yeah, yeah, recorded video it will be share.
So how many days it will be there with us, sir?
Sorry, how many?
I meant to
I
say
didn't
that
get.
yeah, if you say the recorded video, so is it
Mhm.
available for 1 week or can you take off that video from the link, sir?
That will be up to your completion of course.
Okay, okay.
Until
So
you
from the
placed also, they that will be the that recorded will be there.
okay, sir. Till 2 months, only theoretical classes, no, sir. Can't you provide any lab sessions for that?
No, no, that 2 month you will be do lab also, but that is not related to layout. That will be different tool. I mean, Linux you will do, but tool will be provided. You got the point? Tool will be
Ha, ha.
provided,
Okay.
but we will not advanced topic will be covered after 2 month because that
So
is
first
6 month.
two
Our
months,
course will be six. Yeah,
yeah,
first two
yeah,
month
yeah.
you will be learn all the topics,
Uh,
digital topic, PD topic, ticket language, everything will be learn.
sir, you only going to teach, no, sir?
Yeah, I will be teach, but after 2 month, not now. Basic topic I will not cover. I'll go for advanced topic. Right?
Oh, okay, okay. You are going to take the classes after 2 months,
Yeah,
right, sir? So you are going to take the class after 2 months, no, sir? So basic class will not be
correct.
going to take taken by you.
Yeah, basic I will not cover. But
Okay.
layout related basic I will cover only. That will be
Ah,
again after 2 month I will be start only layout basic. But that is purely layout related, not related to digital. Okay, like PD basic also that I will not cover.
daily how many hours, sir? Timings.
Will be timing Saturday Sunday 3 hour, but it depends upon students should be saturated then 2.5 hour, 2 hour 30 minutes like that.
No, no,
But
I am not
minimum
asking. I am not asking about the weekend batches, sir. Daily, from Monday to Saturday.
Monday to Saturday 1 hour you will get.
So may I know the timing, sir?
That is for basic. No, no, that is not advanced topic. Basic class maybe I'm not sure what is the timing, but advanced
Sir.
topic only weekday batch, Saturday, Sunday. Whatever I will take Saturday, Sunday only. You got the point? Because many people are working some software industry, they cannot attend.
Okay.
So our class will be Saturday, Sunday. If any doubt clearing class, that I will consult with student, then I will take only. If everybody is available, then only I will take weekdays. But Saturday, Sunday, I will take only.
So this is the batch only for Saturday, Sunday students, no, sir?
Yeah.
So in WhatsApp, I received a message that there are the classes from Monday to Saturday for one e-learning batches and other weekend batch for the weekend batches Saturday and Sunday, no, sir?
That is for 2 months. I am telling about 2 month. 2 month
Oh,
basic. That may
uh,
be other time. Are you
okay.
getting what? Just avoid the confusion. For basic class, maybe Monday to Friday will be there. But when advance will become, only Saturday, Sunday class will be there.
Oh, okay.
Okay. And
Yeah, yeah.
weekdays you will practice tool. So tool will be some assignment will be given. You will be practice. Okay. And if any doubt, you can ask me. That is for personal doubting. That is not a class. Yeah. Any other having doubt?
Hello.
Sir, can you,
Yeah.
sir,
Uh,
excuse me.
I just
Sir,
joined this. Hello.
Yeah. Tapasin, carry on.
Yes, I joined just now, like just 10 minutes back. So I missed your session. I just got a message now. So I wanted to know, like, as you told, some basic courses will be there. So is it mandatory? We need to go through that course. Actually, I wanted to means opt that course for the analog and this IO layout part. So instead of that, can I opt for
So
only these two?
yeah, it is your choice only. It is not mandatory. So if you want
Okay,
to join directly from advanced course,
okay.
directly also you can join. So
And
it
the
is like a
course,
plus point. Somebody, yeah, tell.
yeah, yeah,
Yeah,
you can.
you're asking it.
I don't know, you can continue.
What I'm telling, this is like a basic course is the 2 month and advanced course is 4 month duration.
Okay,
Okay, so this 4 month will purely analog. I'll be covered that one.
okay. So during that analog part, the topics which you are telling, like SEDES, LDO, ADC, DAC, so all this project related also real-time project you will show, or only the theory part you will just cover? The
No,
real-time.
layout also will be there. Even I will complete the all the plan. Plan means DRC, LVS, for plan routing, everything I will be do only. So whatever the assignment.
You know,
Assignment means suppose that relate.
so.
Yeah, that will be little vary.
Mm-hmm. No, the LDO projects also you will be covering, like the real time, the power blocks, power management modules, which we are doing in the real
Yeah,
time. So some parts you will show how we will do the floor plan of the SEDES, high frequency blocks, all those things you will cover.
yeah. Everything I'll cover. This PLL even also this is a real time schematic.
Okay,
Some
okay.
people also adding even 3 year people also they have added. Even they have selected some. I want to tell one lady name. So she also
Okay.
selected like Altron. She
Mm-hmm.
was having some different background. Okay, she worked initially physical verification. I adding
Mm-hmm.
some real time projects. She also selected 3 year
Okay.
experience by adding this
Okay.
project. Okay, so this is like a some real time schematic will given, not all type. So I'm telling about PL. This is a big project. It consists of you have charge pump, phase detector, voltage control oscillator. Okay, so
Okay.
some real time schematic it will be there. Even shortage also.
Okay.
And
Okay.
one ADC is there. ADC there are many type of ADC. One is flash type ADC. You have uh, SR ADC, successive approximation ADC. Okay, so SR ADC one type for real time. So every schematic will not real time. Some schematic will be real time. PLL, LDO, BGR also one type of real time. So will be given.
Okay. So you mean to say you will be showing both schematic as well as the layout also. You will show practically, right?
Correct.
Okay.
And
And
schematic
one,
operation will be tell. It is
okay.
you will not learn only schematic like blindly. You if you don't know the operation, then layout will not be
Yes.
exact. It will not be
Yes.
precise layout. Okay,
Correct.
so we'll
Yeah.
be tell you some operation, how it will be current flow, why this
Uh-huh.
PMOS and MOS is there. So that operation also will be covered.
Okay. And this is fabrication process steps also you will be covering, no? Like
Yeah, yeah,
all
I'll
the.
cover it. Step one.
So when is the new batch, I mean, only the weekend class is going to start for this layout.
Means when will be start? Sorry, I didn't hear
Yeah.
last point.
No, I am asking like only this, if I want to opt for this layout course specific, so when is the new batch is going to start on the weekend classes?
Exact date will be our admin will be tell, like Manor. You can contact to Manor, so he will give the exact date. Even I am not sure exact. As per the student availability, they are planning because some basic course will be completion. They will be start. Maybe it will take some 1 month time more than even I am not aware of the exact date. So you can talk to our management once.
Okay, sure, sure. If I want to speak to you, can you drop your number so that I can connect, or is that possible?
Yeah, yeah. I'll give the number.
Okay, okay. Actually, currently I'm working in the layout also, but I wanted to do some more, some, as you told, the more fundamental and the more blocks, like say it is, and I haven't done as of now. For that, like I'm just worried. So for that, I wanted to talk to you. So is that possible? Can I connect you?
Okay, okay.
Okay. Can you please drop your number over here? Okay, sure. Then the rest part and the things I will just connect to this admin thing.
Yeah, I'll chat box. I'm giving you.
Okay, sure. Thank you so much.
Yeah. Any other doubt? Have any Kapil, Sasidhar? Anybody else any doubt? Okay,
Sir,
actually the
we can
tool
also
is
contact
not
you now, sir.
connecting now. Sorry?
We can also connect you now, sir. Later, when we will get problem any
Yeah, yeah,
admin
you
or
can connect. It's not for. Yeah, yeah. You can ping me in the WhatsApp also. This.
okay, sir.
Actually, I need to show the tool, but the tool is not connecting for now. So you can talk to our manager. So they will share the tool demo. So we have recorded tool demo classes there. Okay. So already we have already taken 1.5 hour time. There is some issue with my laptop, so I'm not able to show the tool demo. Okay. So if people can contact to our management, they will share the tool demo recorded session is there. Okay. If you are not getting, let me know.
Sir,
Okay,
excuse
sir.
me.
Yeah.
Hello. Hello.
Yeah. You can ask.
Sir, somebody says,
Yeah, I'm able to hear.
uh, which technology you are going to deliver, sir? That is 28 nanometer,
28
something
nanometer.
45.
Correct.
28
That
nanometer,
is
sir.
synopsis. Yeah, 28 nanometer synopsis tool. It is not cadence.
So which one is the latest one,
So
latest technology? Latest one,
latest
sir.
is 3 nanometer. 3 nanometer TSMC 3. Even below is some Intel they have in below nanometer is there also. But 3
So if
nanometer, 5 nanometer, it is no, that is very costly tool. So even no institute is providing that technology. You can ask to any institute available in the Bangalore or anywhere. Okay,
Yeah.
because that is very costly one. So nobody will give you 28 below 28 nanometer. Anybody is giving, nobody will give you. That is I can assure.
Okay. So at the end of this course, that is, if you learn 28 nanometer technology, can you able to do on the 3 nanometer technology by having some modifications? So how we can
Okay,
learn
I'll
that
come
one
to
too?
that point. Okay, so I come to that point. Actually, that is come under FinFET. So I told you one is planar technology, another is FinFET. So for FinFET, there is a difference. So I'll give you some basic point of that. So that for that you need track, grid, fin grid is there. So fin means what? Actually, fin the name comes from one piece is there. Let's take. I'll just try to understand, but it is so FinFET is minimum you need 2-3 year experience. For fresher, directly if you work FinFET, even nobody will allow, even real time also. At least you have to clear about planar technology first. Okay, if you in the real time industry, directly you cannot work. For that you need a basic. If you don't know the operation, then how will you work a FinFET technology? Okay, so FinFET means, as I told you, it is below the 16 nanometer. Okay, so for this the layout challenges. So layout, what is the challenges? You will be one point I will tell you one. There is a called double patterning. This term you will not understand. Okay, so before that many fabrication topic you have to understand. As I told, we have need a grid, track, metal track will be there. So why all these things we need to take care? Because if the channel lengths, let's take an example. So this is the channel. If channel length is reduced, so suppose this channel is reduced. So what will happen? You will take a very less time. So VT will be less. And if you apply some voltage, suddenly means the current will be very fast. Actually, the current equation is there. This equation I will tell you. Okay, so those who are asking for FinFET, the basic thing for 2-3 year experience minimum required. That is why I told initially you have to purely understand. For 1 year you need to understand the planar structure, all the technology. You need to work at least one real-time project. Directly you cannot work FinFET directly. Okay, means you should have some basic knowledge. Not only basic knowledge, you should have some real-time project work. Then only you can go to, because they have some mask also, mask one metal layer. Even you don't know metal layer, if I tell you now you will not understand. Even I told you double patterning, so time being just understand. See, length is channel length. This L is 16 nanometer. Nanometer you understand. Now 5 nanometer. If this length is reduced, the current will be high. If current is high, because this channel is reducing huge number. Current is increasing means what? Number of charges is increasing, which I equal to q by t. Q is number of charges. So number of charges in small area is increasing. Okay, so this is like you will not do. So this is the challenges come. This is one example I'm telling. So in small area, current is means number of charges is increasing. But if you don't do any perfect layout, perfect layout means your layout not like a roughly or any carelessly. In a planar structures, by mistake you did some bending connection. Suppose whatever stick diagram is shown now. Suppose inverter, you have take a device like gate source drain, you connected. But in FinFET, you have to follow orientation. Okay, anyhow, this thing I will cover last class means when you complete all thing planar structure, I'll give you some idea about means how the routing of the FinFET, all these things. So you need to understand. You got some idea, but you need to work on the real time. So this technology not available. If available, I can show. You're getting the point? Somebody asked me how you learn.
Yeah, sir. I got it.
You got the point now, because if I telling you will not able to understand, because many point is if you don't know the orientation meaning.
Ah,
Okay,
all right.
so first you clear about so don't worry about I will learn directly FinFET or low technology. First you learn about some higher technology perfectly, then you jump to there. This is like a last stage. Okay,
Okay. So, what are the major difference,
and for
sir?
yeah, tell.
What are the major difference
Yeah, you can
we must find in between cadence and synopsis, sir?
okay, so synopsis. See, there are many difference, but almost tool will be, if you see the 80% concept will be same. So if you know the concept, you can implement. Concept means you're planning like how you are doing for plan routing, TRC, LVS, almost it will be same only. So here that actually for this is synopsis, we have a for TRC, LVS, IC validator. But in Cadence, they have own Asura for TRC, LVS. Okay, and sometime Cadence they have attached with Caliber. Caliber is the company from Mentor Graphics. But Synopsys we have only IC validator, that is for DRC LVS. Okay, and some command. Command different means suppose we want to align command here it is you are using Cadence A, like some bind key. Bind key means by your if you key in the your laptop there is a some bind key. For synopsis, there is some different bind key. Here also some different bind. That is user defined. You can change that also. There is not a difference point. But the command wise, everything you will find same only. That's why I'm telling 80% almost same. Which are difference thing I'll tell you in the class. Suppose here Excel is there, here Excel connectivity, but here name is different, not Excel. Some naming is different in the synopsis. Here AL Excel in the current AL Excel. Okay. So some layout tool difference. The naming is here some different name, but operation wise it will be same. So what is the difference? I will tell by tool only, but you cannot understand not now. Means you will not understand now unless we start showing the tool. You got the point?
Yeah, sir.
But
Thank you,
time
sir.
being understand. Yeah, if you know the concept, you can work on the cadence also. It's like many people even see last 3 to 4 year I am teaching here only. So there are many people placed in the outside. They are working in cadence now only. Okay, it is not like it will take only, if you know the concept, you can work any technology or any tool also. That is not even caliber also. You can, caliber is very simplest way. Here you will find some DRCL ways tricky, but caliber is very means user oriented. It will show you where is the highlight one very simply. So it is not worried about caliber. I don't know means I cannot work DRCL ways. Okay. So any other doubt? Okay. So thank you all of you.